The first factor that affect the speed of the chemical reaction is, which we are going to read, is concentration. So concentrate yourself. There are some concepts so which you need to understand. Increasing concentration of one or more reactants increase the speed of the reaction. So the reason is, when we increase the concentration of the reactant, so it means there will be more number of the particles of the reactant present in the container. So if there are more particles present, so it means there will be more chances of their collision. And out of these collisions, if there are more collisions, there will be more successful collisions. So there will be more chances. So if there are more chances of successful collision, it means the speed of the chemical reaction will be increased. And vice versa is there. If we decrease the concentration of the reactants, it means the number of the particles will be lesser. So if the number of the particles will be lesser, there will be less chance of their collision, and less chance of the collision. Out of these collisions, there will be even more less chance of the successful collisions. So ultimately the speed of the chemical reaction will be slow. So this is the main idea which we are going to read now. So concentrate now. The higher the concentration, the greater the number of the reacting particles per unit volume. Reactant particles collide more often. So look at, in this container, there are more reactant particles. So they are very close to each other. So when they are very close to each other, there are more chances of their collision. And in this container, there are less number of the reactant particles. They are far apart from each other, so there is less chance of their collision. So it means this reaction will be slow, because the number of the successful collisions will be even more out of the number of the collisions. So look now, reactant particles collide more often if we increase the concentration of all the reactants or one of the reactants. Total number of the collision per unit time will be increased. Frequency of effective collision goes up, hence the speed of the reaction increases. Now we are going to watch a video. So concentrate yourself now. The idea which I have given you about the concentration will be applied here. This video will help you to understand this topic more. So here is the video. The effect of the concentration on the reaction.
The effect of concentration on the rate of reaction. Now look at the colourful flask. Just there, so you didn't notice I changed that side.
So look now. This is a flask in which 50 centimeter cube sodium thiosulfate is going to be put. Place on the cross. So this flask will be placed on a piece of paper on which a cross is marked. Add 5 centimeter cube of the hydrochloric acid into it. So because of the reaction of these two reactants, sulfur will be produced. And the function of the sulfur is, it will make the visibility of this cross obscured. So at a time will come when this cross sign will not be visible. So this is the main idea which is going to be placed, and definitely the solution will be obscured because of the collision of the reactant particles. So it means if the rate of the chemical reaction is more, it will take less time, in which the sign of cross will be obscured. And if the rate of the chemical reaction is slow, it will take longer time to be obscured, to see the cross sign. So this is the main idea. So now concentrate. Okay, when you have put these two reactants into the flask, start stopwatch. Stop stopwatch when you cannot see the cross. Okay, time will be noted in which the cross sign will not be visible. Okay, wash out equipment and measure out 40 centimeter sodium thiosulfate and top up to 50 centimeter cube with 10 centimeter cube distilled water. So look now, the second experiment will be taken with this reactant in which 40 centimeter cube of sodium thiosulfate is used. In the previous 50 centimeter cube was used, but now 40 centimeter cube is going to be used, and 10 centimeter cube of water is added to make it dilute. So it means we are actually decreasing the concentration of the reactant. So if the concentration of the reactant is less, so it means number of the particles of the reactant will be less as that of previous experiment in which 50 centimeter cube of sodium thiosulfate was used. So now 40 centimeter cube of sodium thiosulfate is used. So it means number of the reactant particles will be less. There will be less chance of their collision as before as compared to previous experiment. So that this experiment will take longer time in which this cross sign cannot be seen. So look now, pour both the sodium thiosulfate and water into a conical flask on top of the cross. Add 5 centimeter cube of the hydrochloric acid. So hydrochloric acid's concentration is same, but we are actually decreasing the concentration of the sodium thiosulfate from 50 to 40. Okay, start the stopwatch. Stopwatch when you can no longer see the cross. Repeat with all the amounts in the table. So look now.
Right, here it's doing the same reaction as we did with temperature. This time we're changing the concentration of one of the reactants. It's going to add it to acid, and we are going to change the concentration of the sodium thiosulfate. When you add sodium thiosulfate and acid together, hydrochloric acid, it forms a precipitate called sulfur, which is a solid. It's a precipitate, that's what that means. So it's insoluble solid, which makes it go cloudy and you can't see the cross anymore. You change the...
So these are the experiments which you will repeat. Like first experiment will be taken with 50 centimeter cube of sodium thiosulfate, second with 40, third with 30, next will with 20, next with 10. Because we are adding water, more and more water, it means in every successive experiment the concentration of the sodium thiosulfate is less, so it means time taken will be more. So whatever the time taken in the first experiment, the next experiment will take more time, the next experiment will take even more time, and up to so on.
Amount or volume of sodium thiosulfate, and that reduces the concentration of sodium thiosulfate. Really bad table there, no units at all, so that's what not to do. Does it tell you anything, is it? 51 gallon? Right. Anyway, so this one is the most concentrated because it's not diluted by the water at all, and then they get progressively more and more diluted. If I then plotted the results, it's a nice stopwatch. If I then plotted those,
so the results of the table which you have obtained by repeating the experiment 5 times or 6 times or 4 times, the values of the table will be marked on a sheet of the graph paper. So look now, here is the volume of the sodium thiosulfate and here is the time taken for cross to be disappeared. So for example, when the volume was 50, the time taken may be 1 minute. So 1 minute and 50 point will be marked, and up to so on points will be marked of all 4 or 5 or 6 experiments. So look now.
So it's a bit of just move the phrase a sec. Then I would end up with the graph that the volume was really low, the time taken would be very slow, and you'd end up with this sort of downward trend. So you could get all sorts. Of course, you'd also then show it another way where you've got a graph going that way. Just got to read what it says so that you can understand what's going on. So in this case, you'd say as the volume of sodium thiosulfate increases, the time taken for the quantity to disappear decreases. It's the negative correlation. It's as one goes up, then one goes down. And to explain why, which is pretty straightforward, we can say here, if we have got some reactants.
So now the video is actually showing us the number of the water particles, and this is the particle of sodium thiosulfate. So it means if there are more particles of the sodium thiosulfate, rather these are the particles of ACl, and this is the particle of sodium thiosulfate. So if there is only one particle of sodium thiosulfate, so there will be less Coulomb, so the speed of the reaction will be less. And if we increase the concentration of the sodium thiosulfate, that represent orange circles. So if there are more particles of the sodium thiosulfate, so they will make more Coulombs and speed of the reaction will be increased. So this is the thing which is now you are going to see.
Actions. We've got some reactions here. So we've got some green reaction with orange, and we increase the concentration of the orange, so we put more and more of them. There's a faster and faster the reaction will be, so more likely they would be to collide successfully.
So look now, the number of the particles of the sodium thiosulfate are increasing now. Actually, we are increasing the concentration of the sodium thiosulfate. So the sodium thiosulfate and ACl particles will collide more frequently because number of particles are more. So the speed of the reaction will be increased.
It will collide. So it would be a quick reaction. So for concentration, remember you can only increase the concentration of one of the reactants. If you increase the concentration of both of them, you're sort of ending up with the same thing as you had before, just more of it. So if you use a more concentrated solution of one of the reactants, the reaction is faster. This is because there are more particles present. They're more likely to collide with the other particles. The more successful collisions there are, the faster the reaction. The key point you've got to be the more particles, more likely to collide. Successfully. Yeah. Okay, so that was.
So here is the key point. If there are more particles, more likely to collide successfully, and the rate of the chemical reaction will be faster.
Faster reaction. I've got a question in this one, just a bit tricky. Here we've got that there, that's the exam question, it's got that one on there. And you're investigating.
So this is a sample of question paper which you will see in the paper number 4 of chemistry paper, or this question may also come in the paper number 2 of chemistry as well. So this kind of the figure will be given and question will be, the results are shown on the graph on the opposite page. So now you will mark the different points on the sheet of the graph paper that you have obtained into your table, and then you will draw the line of the best fit. The line of the best fit is actually a line that almost pass through in between of all the points. So the line of the best fit is actually a line that actually passes through most of the points which are marked on the graph paper, which you will see in the video later. Okay, first part is draw the line of the best fit on the graph, and the next part will be suggest two reasons why all the points do not lie on the line of the best fit. So look now.
And to change the concentration of sodium thiosulfate affects the rate of reaction. Obviously, you would read all this carefully, so you can pause it. And then we go to the question. Drawing a line with the best fit on the graph, that's here on this one. So your line.
So this will be a figure that you will draw. So here is our graph paper. This is the result of the first experiment. Look now, concentration of the sodium thiosulfate, and here is the time. So this will be the first point that is actually obtained from the first reaction. This is the mark of second reaction, third, fourth, fifth. So you have performed 5 or 6 experiments. So 5 or 6 points will be made on the sheet of the graph paper, and then we have to draw the line of the best fit through it. And line of best fit is a line that passes through most of the points and passes through in between of the points. The points above the line will be almost equal to the points below the line. So because all the points will not lie on the line of the best fit, this is the point to remember. Line of the best fit will not pass through all the points, but line of best fit will pass through maximum points, and the points above the line should be almost equal to the points below the line. So look now.
They'd have a ruler, because that's rubbish, and it'd be a straight line.
But you will draw this line with the help of scale, not like this. This is the point to remember.
Line down there, missing out this point. Obviously, normally. Okay, so just 2 reasons why all the points do not.
So look now. This is very important question which frequently come in the paper. Suggest 2 reasons why all the points do not lie on the line of the best fit.
Line of best fit, that's talking about errors and what you haven't measured properly, etc. So that's that. And then in conclusion to the investigation, students stated that the rate of reaction is directly proportional to the concentration as the.
And this is the most important question which frequently come in the paper. The rate of this reaction is directly proportional to the concentration of the sodium thiosulfate. So the question is, the rate of the chemical reaction is directly proportional to the concentration of the reactants. How does the graph supports this conclusion? So when you will draw the line of the best fit that passes through the origin, so that will be a proof that the rate of the chemical reaction is directly proportional to the concentration of the reactants. So look now.
Graph support this conclusion. That is because it is a straight line going through 0, 0. That's the main point. So what that straight line going through the origin. 0, 0. And then the great favourite, explain in terms of particles what's happening, and you use what we just.
So look now, you will write this answer that will support this question, that rate of the reaction is directly proportional to the concentration of the reactants because the straight line going through the origin. So this is the answer.
Okay, the effect.
Okay, moving ahead, a yellow precipitate, because when you will add sodium thiosulfate and HCl in the flask, a yellow precipitate is produced in the reaction between sodium thiosulfate and hydrochloric acid. These 2 reactants are going to be react. So sulfur will be produced, which will be responsible for making the solution obscured. So the rate of this reaction can be followed by recording the time taken for a given amount of the sulfur to be precipitated. This can be done by placing a conical flask containing the reaction mixture onto a cross on a piece of paper like this. Flask will be placed on a sheet of paper on which a cross mark will be drawn. The rate of this reaction can be followed by recording the time taken for a given amount of sulfur to be precipitated. This can be done by placing a conical flask containing the reaction mixture onto a cross on a piece of paper. As the precipitate of the sulfur forms, the cross is obscured and finally disappears from view. The time taken for this to occur is a measure of the rate of this reaction. To obtain sufficient information about the effect of changing the concentration of the reactant, several experiments of this type must be carried out using different concentration of the sodium thiosulfate or hydrochloric acid. So the concentration of any one of the reactants can be changed. Some sample results of experiment of this kind have been plotted. So look now, when the concentration of the sodium thiosulfate was 50 centimeter cube, time taken was 30 seconds. So this is the point which is the result of the first experiment. In second experiment, when we put 45 centimeter cube of sodium thiosulfate and 5 centimeter cube of water, so definitely the concentration of the sodium thiosulfate will be decreased. And in this experiment, the time taken will be almost 39 seconds. So this will be the point marked. In the next experiment, you will put 40 centimeter cube of sodium thiosulfate and 10 centimeter cube of the water. So the reactant will get even less concentrated. So in this experiment, almost 49 or 48 seconds will be taken for the mark to be disappeared and up to so on. So this is the shape of the graph. You will note from the graph that when the most concentrated sodium thiosulfate solution was used, the reaction was at its fastest. This is shown by the shortest time taken for the cross to be obscured. And here is a short question. In 4 separate experiments, identical samples of the magnesium ribbon were added in excess of the hydrochloric acid, which experiment will give off hydrogen most rapidly. So it can be seen from the table that concentration is maximum here. So this will be the A part experiment. So A, it has the highest concentration of the acid. The higher concentration of the acid results in higher frequency of the effective collision between reactant particles. So this was the question.